I have constructed a very simple front-end program. That's the user, we or I. I'm interacting with some JavaScript program. It's running in the browser, and the JavaScript program sends time as a number. It's Unix time, but it doesn't matter, to the backend. And then the backend magically determines some string that's time as a string and returns it. And then the JavaScript displays the result and the user sees the result. So it's a very simple use case. You could do this in JavaScript actually, but let's just assume it's some magic. What string is determined, that's not possible in JavaScript. So I wanted to show the program first, kind of for anybody who is interested. Oh, that's my slides. I have that's too small. I can make this one larger. Okay. So the front-end program is one single file. So in larger programs, usually you split the program in many files. I just want to gloss over it. It's some meta information that this is an UTF-8 file, so the browser will display all the umlauts correctly. You see, I didn't do all the HTML and head stuff because the browser will render it anyway. The style, it's just some CSS style. I won't go into it. Then let's look at the initial DOM. It's very simple. We have a div. You will see it later. And then one button. You can click the button, and then this is the result. And the JavaScript, on button click, we look at the current result element. So we search the element. Then we prepare the request. It's a post request. So in web, there is different kinds of requests. This is a post request to some URL. And the request body, which just is the timestamp and the current date as integer. Just a little in between, because I wasn't sure how much of you have already did something with JavaScript. So yeah. Okay, so if I say that's an XML HTTP request, you know what it is. Yeah, okay. So it opens the request, sends the request, and then this is executed if the response is here. It assigns the result from the response text to the text content of the result element. And that's the whole front-end program. It sends the time to the backend, receives the response, and assigns it to the result element. I will now start the application. I prepared something in Docker. No, where am I? I'm in the wrong directory. So let's go into the web server. I will not go into the Docker Compose specifics. Basically, I'm starting a virtual container in the background that starts the whole web server stuff. So, and I will open what the web server gives me. So it's very simple. We have one div. I made a blue line around the div for better finding it. We have one button. And if I press the button, then the backend will generate a time as string, and the string is displayed. So it's a good use case to show it. Okay, but what actually happens? So this talk is about what happens in the background, because if you're in a big project and something is wrong with the string, if you tell the backend developer, well, this string is wrong, then the backend developer will think, oh, I have to think about all the front-end stuff. And in big projects, you have so many libraries in the front-end. Backend developers don't like to think about front-end libraries. So if you cannot negotiate with the backend developer to think about the front-end stuff, maybe you have to analyze the next step yourself. So what is the next step? If we look at what happens in the background. So user clicks on JavaScript, but JavaScript actually just sends some instructions to the browser, and then the browser will send an HTTP request for you to the backend. And in modern browsers, let's make it big again, there is some secret hotkey. Well, you can Google it. In my browser, it's Ctrl-Shift-C, and it opens developer tools. And developer tools are very handy because they have a network tab. So all the other stuff is about Java. JavaScript, I'm a backend developer. I don't care about JavaScript. But I care about the network tab because that is what is seen by the backend. So, and if I now press the button again, it will notice the time. It will send the request again with the updated time to the backend. The backend will send an updated string. And what then is here seen, this is the HTTP request. If you look here, JavaScript will send to the browser the instruction to send something, and then the browser will send an HTTP request for you. And these developer tools can inspect those requests. Let's see, one per line. I already clicked it, and we see the details. It's very small. It's very small. So you have to believe me. I don't know. I guess anybody that's interested in has to come to me afterwards and look at the laptop again. But to summarize it, this shows all the properties of the request. Where is it going? What exactly is in the request? We have a request URL method, HTTP version. There is version 1.0, 2, 1.1 in this case, response headers, request headers, and all this is sent to the backend. So even though in JavaScript it was just one small timestamp, the browser adds other stuff. And the backend cannot do anything about the browser. So if a problem is here, the wrong thing is sent, then backend cannot help you. But it's important to look at it. Yeah, it's just too small. I will look at the same. What is the next level? Sometimes the browser is not low enough because browsers have, I wrote it down here, I hope big enough. They have the same origin policy, they have a core security policy, they have HTTP only cookies, so maybe the JavaScript doesn't see all the cookies, and etc., etc. There is some library, Swagger UI, I didn't bring it up today, but it basically helps how to communicate, how backend developers communicate with front-end developers, and you can click and it's all fancy. But if something doesn't work, maybe it's because of some wrong cookie, and the Swagger UI cannot access this cookie because it's an HTTP only cookie. And then, if we have this kind of problem, and maybe you want to send an email to the backend developer, and now you could only send a screenshot. The next level, we can just circumvent the browser. We don't execute the JavaScript. We don't use the browser. There is the possibility in Linux and Mac. I don't know about Windows, but I guess it's possible to send a HTTP request directly. That circumvents all the security stuff in the browser, and that's a nice way to check if the problem is with backend or with some browser configuration. And that one I can make large. So, because I have bad eyesight, I need a large. So, the program I want to show today is curl. It's a usual command line program. I have prepared some options. I shows additional stuff. And then the first option, xpost, it just wraps around. So in reality, that's one line. It just wraps around for this display. Post, we have get method, post method, head method, put method, delete method. In this case, there is some agreement between backend and frontend what to use, and in this case, I just decided the use post, to implement the backend to use post. Then content header, because today it's the latest hype to send everything in JSON and receive everything in JSON. And in an HTTP request, it is declared what is sent. We could use a binary image, but in this case, I'm adding the header, H, that declares that the content I will send is JSON. Then I'm including the content itself. Just believe me, it's valid JSON. I didn't bother calculating the time number. I just used any number. It's 9 with how many? 1, 2, 6, 8, 3, 8 nines. That's just some date. I will correctly close the JSON document again. And finally, I'm specifying the URL where I'm sending the request. Because I configured Docker the way I configure it, the backend is running on this URL with HTTP, so no security whatsoever. Then localhost, I'm running it on my local machine. I put it on port 42114. And just for good measure, I prefix the URL with API v1 and submit. I'm assuming URL. Everybody knows what the URL is. So I'm sending this post request with a certain header and a certain request body to this URL. And enter. And now command line. It's difficult to read because in Linux, it's usual if I press enter, the output of the command immediately starts. So there is no nice separation. That means what curl is giving me back immediately starts here and goes until here. The backend did not send a new line at the end, so there is no new line there. So you have to read a curl response. It's not graphical, it's backend. So what is the response? And curl does not print in this configuration, does not print what is sent, only the response from the backend. So the backend responds with some HTTP 1.1 response that would be 1.0 and 2 or 3 I hear are in the works. 200. Well, if you don't know what the code means, just Google it. There's a whole Wikipedia page on it. Then date, when this response was generated, but that's not the result in this case. So it's when the response was generated and not what the backend told us. Then some server information. The backend was kind enough to also respond with content type JSON. It's some transfer encoding. We could have, for example, transfer encoding zipped. If it's big data, backend could choose to zip the response so it's smaller, compress, or gzip, or 7zip, or whatever. And then, because HTTP has always an empty line, there is an empty line, and then there is the response body. And this is now what really the backend generated. The backend sends a JSON document with one property, formatted timestamp, and now this is the string. And it just so happens that the 9 with 12, I think, was it zeros, is in 1989. So I was born in the last millennia. That's why. Yes, and that's the whole thing. Now, if this is the request gives a wrong result, you could send an email to the backend developer and say, well, I use this curl and it gives the wrong result. And the big advantage is that even if the backend developer is working on some strange operating system, he can reproduce, or she actually can reproduce it. Because a browser, maybe you record a video and say, I click here, then it's maybe not possible to reproduce it that reliably. So maybe what the backend developer is doing on his laptop and you're doing on your laptop are actually different things. And with curl, the big advantage is that the likelihood that you're talking about different things is lower. But there is more, because that's just HTTP request. We can go even one step lower. We cannot send an HTTP request, but make a TCP connection ourselves. That's fun, because what if curl is in the wrong? It actually happened to me once in my lifetime that curl gave a wrong result. So what can be done? I will not explain the syntax, but there is a program called ncat, which does nothing except making a TCP connection, and whatever you type in on your laptop is sent unaltered to the other side, and whatever the other side sends to you is displayed unaltered. Curl already does all the chunk encoding in HTTP and status code analyzation and stuff. ncat doesn't do that. So I'm sending to localhost 14112, and let's first see ncat. Now I have pressed enter and made a TCP connection to localhost 42114. And nothing happens, because that's how HTTP works. The server is waiting for the client to do anything. And I could write hello, press enter. And what happens now is I typed hello, sent those actually 6 bytes to the other side, because it's HELLO and then an enter. And the server responded with, because it's an HTTP server, it responded with the correct HTTP response, some bad request. This response was generated at this time. The server was an Apache server. The content length of the response, the server had enough of my wrong requests and closing the connection. And the response content is actually HTML. It basically displays the error message again. So if this request would have been sent by a browser, the browser could display a readable error message. What I actually want to do, I want to show a correct request. So I wrote it down beforehand, because otherwise I will mistype. So it's post, so I'm sending those 5 POST space bytes, API, the URL, submit. Then I'm declaring it's 1.0, because it's easier to type 1.0 than 1.1. Host, local host, so I want to speak to local host. Then I'm declaring my content type, what I will be sending. I'm declaring the content length. For example, that is something that curl will automatically determine. And then my body timestamp, oh, no space there, because I declared the content byte and it's in byte, the content length, it's in bytes, so no space allowed, because otherwise 27. So 9 and 1, 2, 3, and 4, 5, 6, so, and enter, AOF, enter. And that's the response. It's the same response as displayed by curl. So curl is actually very low, but if there is some, well, I never actually used ncat in my life for this purpose, for analyzing, but it's nice to know that there is actually something. I actually then use some other program and use an inspection tool that will display the bytes on the TCP stream, so I don't have to type it all myself. And the main thing I wanted to show is this curl stuff, and that's it.